Hello there, my name is Kevin Vasquez, and I've been working with Alex Benitez and Matthew Zertucci. We're going to be going over the script and user-defined function that was used to solve the circuit analysis problem for Project 3 in Engineering 1331. So, quick background of what the tasks were. We had a schematic diagram of an electrical circuit that had voltage source V1 and V2, and three different resistors, R1 through 3. We had to determine the current running through each of the three resistors. And in order to do that, we had to use three different laws and equations. So, first, Ohm's law is just voltage through any electrical source is equal to current times resistance. In addition, we used KVL, Kirchhoff's current law, which just says that current traveling into a node must equal current traveling out. So we had currents 1, 2, and 3. The circuit basically had two voltage sources, and R1 and R2 were in their own branch. R1 was in the V1 branch, R2 was in the V2 branch, and they both fed together into resistor 3. So that just means that I1 and I2 feeding together into the same branch will equal I3 at the end. Finally, we had two Kirchhoff's voltage law equations for each of the two branches, V1 and V2. And this right here is just the laws for resistors getting added in series. They just get combined via addition. So finally, these are the equations we want to determine I1 through 3. So I1 is initially only in terms of known voltage and known resistance, which is kind of given right here. V1, 2, R1 through 3. We then take the I1 value, put it into the I2 equation, which is much simpler to determine I2. And finally, I1 plus I2 is equal to I3, which is the KVL equation that we defined earlier. So this right here is the user-defined function. It has the same comments as in the overall script. And here are the equations and code that was used to actually determine the real values. So again, the format that we chose to use if we run this portion is just a fprintf statement that we formatted into a table. And again, problem statement, and we have voltage values in volts, resistor values in ohms, and current values in amps. So that was task 1. Jumping down again to task 2, what we basically had was some sort of a manufacturing specification that basically said that through each of the three resistors, there cannot be more than 1 amp traveling through each, and we don't want to have current values in the negative, so not lower than 0. Given these restraints, we needed to determine the maximum and minimum voltages for V2 that are allowed. So what we had basically is we have these input variables, and then in the event that they're inside or outside of some kind of a range, we're going to use these intermediate variables as well as the code to run a larger if-else statement. So this is what we really want. We want V2 max and V2 min. So looking at that if-else statement that we're talking about here, what we have is that if I1 through 3 start out less than or equal to 1 or greater than or equal to 0, that means they start out in an acceptable range, and we run this part of the code, the if. So we redefine V2 as V2 max and V2 min. So looking at V2 max. V2 max starts out the same value as V, and all we do is we count up by 0.001 over and over again until it is outside of the range. So as long as it's still within this range, C equals 0, and the while loop continues to run. As soon as it doesn't meet that condition, C has 1 inputted into it, breaks the while loop. And again, we counted outside of that acceptable range, so we have to correct that overshoot by subtracting 0.01. That's how we get V2 max. V2 min is determined the exact same way. Instead of counting up adding, we subtract 0.001. And again, we run the same logic until we break it. D will then equal 1, and we correct that overshoot. So that's the if branch. Now, if we run the else branch, that means that I1, 2, and or 3 do not start out in acceptable ranges. So what we have to do is we redefine V2 as a V over min and a V under max. So essentially we're going to count up and we're going to count down until either we hit a minimum for a range that's over the starting V2 value, or we're going to count down until we hit a maximum of a range that's under the starting value. So this is that logic expressed in code. In the event that we hit that minimum of the over range, we're going to store the V over min as our V2 max. So I'm sorry, as our V2 min. And then all that we do is we'll just do a quick while loop in this if statement of the larger, just do this up, of the larger else statement. So again, in the event that we hit a maximum, in the event that we hit a minimum that's in the over range, we'll just continue to count up until we exit acceptable ranges. F will equal 1, breaking this while loop, and then we'll store our maximum as that. Same thing if we hit a max that's under our initial value, we will store V2 max as that, and then we will do a quick calculation of the minimum and store it as V2 min. So again, let's go ahead and run this next section, and this is what we get as our formatted output problem statement, and we have maximum and minimum allowables, 34 and about 4 volts. So that was task 2, and then finally for task 3, we had to run the same concept as was in task 2, except we had to change R3 resistance values anywhere from 15 up to 115 ohms, and we counted by 1 ohm for each step. So what we had to use for that was a very large for loop, and what we really wanted to determine was what is shown in this graph, the maxes, minimums, and averages at each resistance value. So for that, jumping to the user-defined function, we had a very large overall for loop, counting from 0 to 101. And then by adding 14, that simulates the resistance value of R3. And we, for every single Z counter value, we looked at, okay, is it inside? Does it start inside or outside? And we had to run that same large if-else code. And what we do basically is, in the event that we find maxes and mins, we save it as our V2 ohm max line at location Z, which represents 15, the 15 ohm value for R3. We'll also do the same thing if we hit V2 ohm min. This is the minimum value of that V2 given the ohm value of R3. And so what we create is we create a 101 value, two different vectors, maxes and mins. And then all we do is we graph it along a domain, and this is our actual output that we really wanted in the end. So again, this was task 3. We have maxes, minimums. This is overall. So we did a quick, here's the code for the plotting. And we had all the plot commands, and we did max, min, and averages of all of that, all those values. So again, this was the end, what we wanted, and this is the conclusion for the tutorial of our circuit analysis problem for Project 3. Thank you again for watching, and hope you have a nice day.